Now we are going to determine whether two given functions are inverses. It says we now have enough background to define an inverse function. I don't really love that they call this the definition of an inverse function. It's not really the technical definition that I've seen before of an inverse function. It's really more of like properties of two functions that are inverses. All right, so we have f that must be a one-to-one function before we can even discuss whether or not it has an inverse. That's why we have to see if our original function f is one-to-one or not. Okay? Then if that occurs, then g is going to be the inverse of f if the following conditions are both true. That f composition g of x comes out to be x for all of your x in the domain. And then the other way around, g composition f of x also comes out to be x. Okay? So you're going to do the composition both ways. And if that g function is an inverse, well, let's call it what it is. It says we should also note that if g is the inverse of f, then f is the inverse of g. Furthermore, given a function f, we're going to denote its inverse as f inverse. Okay, so that's how you read this, okay? You read this as f inverse, and listen to this, not f to the negative first power. If you say that's f to the negative first power, you will be wrong, and that is what this purple box down here is all about. Okay, so the way that, I'll talk about that in a minute, but the way that this says is we could go back up here and replace f inverse notation for g. So we could say, well, we got to satisfy these two conditions. F composition f inverse of x gives you x, and the other way around, f inverse composition f of x also gives you x for your answer. In the purple box on avoiding mistakes, do not confuse the inverse notation. Remember, we read that as f inverse with exponential notation. Don't call it f to the negative first power. The notation f to the negative first power does not act like the first power, the reciprocal. Okay, that's not how we're going to find an inverse. Okay? All right, let me go to the next slide, and it gives us a couple of different functions to work with, and we're supposed to determine whether the functions are inverses or not. Okay? I'm going to go ahead and scroll a little bit here. Now, remember the way that we have to determine whether those are inverses. There's two different things we have to look at. And let me go ahead and color code these a little bit. We've got the h of x function, and we've got the k of x function. Okay? The first thing we're going to do is we are going to evaluate h composition k, understood to be of x. Okay? And if these are inverse functions, okay, we're going to get x for our answer. Okay? Now remember what this means. H composition k of x means our outer function is the h function, and we are going to evaluate that at the inner function, which is k of x. All right, so let's work on this a little bit. So we are going to have h evaluated at, replace k of x with what it is equal to, says right up there in the red box, that k of x is equal to x plus 3 all over 7. Okay? Now if you're going to evaluate your h function at x plus 3 all over 7, you're going to go to that blue h function, and where you had an x, you're going to replace it with the x plus 3 over 7. So my h function says 7x minus 3. But like we said, instead of an x, you're going to be putting in x plus 3 all over 7. Now it's going to be a matter of simplifying some things. Okay? So when you step back here, your 7s would reduce, leaving you with x plus 3, and then bring down the minus 3. What's x plus 3 minus 3? Right, that's just x. So we're halfway there, okay? Now, the other way we have to do this is the other way around. We've got to show that K composition H evaluated at x is also going to give us x, okay? Now, this time, the outer function is the K function. So I'm going to take K and evaluate it at the inner function H of x. Okay, so that means we're going to do K evaluated at what H of x is equal to. Says right up here in the blue box, H of x is equal to 7x minus 3. All right, now what this is telling you to do, K evaluated at 7x minus 3 tells you to go to your K function and where you had an x, put in the 7x minus 3. Okay? Now, our original K function says we have x plus 3 all over 7. So let me write x plus 3 all divided by 7. And I'm going to replace the x with the blue stuff, the 7x minus 3. Okay? Now it's a matter of simplifying some things. In the numerator, those parentheses are not essential, right? So we can do 7x minus 3 plus 3 falls out. Y'all, that leaves us with 7x divided by 7. And then you will see that the 7s will reduce. And so we get x for our answer here. So would you say h and k are inverse functions? Well, because these two things happen, I would say yes, they are inverse functions. Okay? Let's look at number 34. Again, we'll color code this into P of x and Q of x. All right, so first test is to see if P composition Q, and that's understood to be of x, if all that will simplify to give us x. That's the big question. Okay? Now, remember, P composition Q means our outer function is the purple function P, and we are going to evaluate that at the inner function Q of x. All right, let's work on that. So we're going to evaluate our outer function, the P function, at what the inner function is equal to, which is 4x minus 3. So let's do that. P evaluated at 4x minus 3 tells you to go to your purple function and where you have an x, plop in 4x minus 3. Okay? Now, I'm going to have a negative 3 plus my function that I'm going to replace for x, all divided by 4. But instead of having an x, I'm told to evaluate it at 4x minus 3. So there it goes. And now it's a matter of getting some things simplified. All right, so in the numerator, we have negative 3 plus 4x minus 3, all divided by 4. And so when I go to simplify that, I'm going to have 4x minus 6 all over 4. Uh-oh, this isn't looking like P and Q are inverse functions. Even if I would go along to split this fraction and write it as 4x over 4 minus 6 over 4, what I'm getting for P composition Q is not x, right? It's actually equal to x minus 3/2, okay? So since P composition Q is not equal to x, that means that these things are not inverses. So I would say P of x and Q of x are not inverses. Okay, or I'd say inverse functions. Or you know what, I might just say no. Okay, if it asks are those inverse functions or not. No. Okay?